of what Obamacare has done to their families. 3 times the amount they're paying for premiums. They don't go to the hospital because of the out-of-pocket costs. They lost their doctor they've had for 27 years. A woman who's a nurse who wants to stay at home with her 4 children now has to decide, gosh, I don't know if I can do that because the insurance is so expensive. Meanwhile, I get it right now from the hospital. This is craziness. So tell those stories and tell them much better than you're telling them right now.
Okay. Hi there, radio fans. It's Bob in N1KPR. My website, bobsamerica.com. Today we're looking at an off-air monitor. It was built for a small radio station down south. The idea of this thing is that they can monitor their own off-air broadcasting, and should the station go dark for any reason, or they lose signal, lose a transmitter, lose feed from the console, the STL goes down, something, this thing will do an automatic switchover and keep the station on the air. And it'll provide its own feed from your digital recorder or some network or syndicated program that's coming off the satellite dish, or however you want to do it. But the main thing is that the station is not dark during an internal problem. So quickly, I just want to go through this. If you've seen my other YouTube videos, you know that this is the type of stuff we've been doing for quite a while. There's many more units of varying flavors that are like this. So let's do this. Over here we have the off-air or silence alarm monitor, and if you can see, if this will focus, we're allowing anywhere from 0 to 20 seconds. So I'm going to set it for about 5 seconds, and I'm going to kill the antenna. You may also want to see here, we're looking at the carrier audio, the actual modulation. If there's any significant modulation, this will be indicated, and of course detector action. And here we have voice with data and no data. So, all right, let's kill this, and we lost the feed from the console, and all your audience is wondering why there's just a carrier coming into their radio. So here we go. 1, 2, and there we go. We're off air. The internal relay is kicked in, and now you're sending out some pre-canned audio. So nobody's the wiser that you've got a problem in the studio. Maybe the clumsy janitor tripped over the wire and yanked it out. Who knows? You blew a fuse, there's a storm, the power's down, the generator didn't kick in right, whatever. You're running on backup, and you're okay. We'll bring the antenna back, and there we go. Also notice that these indicators are instantaneous, and they're exclusive of the timer. Let's do it again. And keep an eye on the green here and the indicator here. Here we go. Off here. And 5 seconds later we kick over. Okay. Quickly going through the controls: antenna and shunt with true RF gain control. A preamp if you're out in the field and you want to do measurements, or you want to check the competition or adjacent channel noise, or whatever you want to do. We could essentially double the input signal. I've got 6 dB of gain in the preamp. Actual preamp gain here, so you can go from 6 dB down to 3 or whatever. As a matter of fact, we could probably trip this whole thing by killing the gain. There we go. We lost the carrier. See? And that is true RF gain, attenuator here, and true RF gain here. Of course, the seconds in the indicator for the silence alarm or delay. We do have the carrier audio and modulation sensors here, and each one has a switch you can send to an output at the back, which could trigger an alarm in the studio or whatever, if you really had to know that. We're using an Innovonics 634 module for the tuner part. The antenna feeds an analog signal, and after that it's all digital until we get to the audio. It's a very nice unit. There's a lot of setup parameters that comes with it. Lost signal level, signal to noise, analog or audio loss, timing, left and right signal levels, headphone monitoring, and so forth. You can set up the de-emphasis circuit, the IF bandwidth from around 2K all the way up to 6K, and the AM spacing in case you happen to be in Europe instead of America. Over here we have modulation indication, which is integrated. If I go to peak, you can see the actual modulation of the signal, which is integrated to about a second and a half. And if we go to RMS, which is not true RMS but close enough, you can see about a 4 or 5 second level integration. We also have that back here on the data and space indicators. Right now we're in an RMS mode, and you watch them speed up. This is now pretty much instantaneous, just seeing what the detector is putting out. Make it easier on everybody. We go back to RMS. Over here, the actual envelope levels, so you know, and these are calibrated to whatever the nomenclature tells you. Line level, which is going to be feeding a monitor system or your recorder, because you might want to do proof of advertising recordings for your the people that pay you to stay on the air. And monitor level, which kind of comes in handy if you're doing a remote somewhere and you want to play a PA system or something for the guys, for the audience or the visitors. Have audio in and out, which is just a cue device. And you know, I'm going to kill this one so we can hear the real one. We'll turn it up.
Any of these people, I don't think anyone wants to hear them.
And they're, you know, now we've lost the audio. Now we can queue up through the headphones and then go online whenever the guy says go.
Agenda, and they're presenting that platform to people like her.
Again, this will be constant because it's the feed from the tuner. This is the feed you're going to send to the actual console, the board, the transmitter, whatever. And down here, of course, the power level.
Getting a little bit too political. She got suspended. The only difference between those two is
as you drive the PA system. We have 2 monitor speakers, internal, external.
Privately held company. They can say
I doubt if you could hear any difference on this recorder, but
you're not what you actually are.
There's a big speaker out in the room.
That's where I think the rubber's going to meet the road.
And there's an internal one. And of course, power. Well, that's basically it. Let's run through the insides. I'm going to get a little light on the subject here. I don't know if that helps or makes it worse. Probably makes it worse. Indicator drivers, tone and broadband compensation, the metering circuits here, which are all calibrated by this pot. We got a little power amp. Got a nice, stable, regulated power supply here, these 2 guys. We're filtering the AC coming in. Gotta be careful touching that thing. The outputs for speaker, line, and raw audio. 3 different RF inputs, which we could see back here. We have SO239B and C and a F59. Over here, we're doing a lot of antenna filtering and static bleed and nearby strike transient suppression. We're also cap coupled, so we don't have any DC static bleed coming into the radio. Here's our little 6 dB preamp, which actually could handle up to 20 dB, but you really get into overload situations with that. The relay switching for the indicators that you're going to put out in the studio. You might want to hang a big red light out there that if the red light comes on, the DJ can actually say, uh-oh, we're not, I'm talking, but nobody's hearing me. Or if not, you don't have to. You just walk by the, hopefully there's a big glass window in the control room. You can peek in and come back here and say, well, I don't see any red. No red, that's good. Green is nice. We're using some diode logic here for the switching. This is the timer, relay circuits, and the driver board for it. Over here we have the control circuitry for the modulation detection and modulation percentage, and 70 to about 110% modulation. That's the way it's calibrated now. We could always set that up differently for somebody. So that's it. Very basically, it's a very, if you're into listening, it's a very nice unit to play around with in the evening. I like to sit around and go every 10 kilohertz and see what I could hear late at night. I usually use the big 160 meter amateur radio antenna for AM, because you're pretty close, this being 1 meg center band and the 160 thing being at 1.8 to 2 megs, so you get a lot of capture. Well, that's basically it. I'm going to call this part 1 because last time there was a bunch of questions that came in, and we'll try to answer those as that happens. So thanks for looking. This is Bob, N1KPR, my website, bobsamerica.com, and I really want to thank you for showing interest. Leave comments if they're good ones, and we'd appreciate it. So let's go off the air. N1KPR signing out. Thank you.